Confounding. Students will be able to describe confounding in the context of an observational study or an experiment. In the previous video, we looked at the difference between an observational study and an experiment. We said experiments, when well designed, can show you cause and effect relationships, while observational studies cannot. This is because of something called confounding. Confounding is when two or more variables are associated in such a way that we cannot determine which is affecting the response variable. So imagine we wanted to do an experiment where we wanted to test different types of fertilizer on plants. There are a couple of confounding variables that could occur if we did not control for them. For example, if some plants got more sun than other plants, or some plants got more rainwater than other plants. If we don't control for these variables, then how can we be sure that the growth in one plant is actually due to the fertilizer and not the amount of sun or the amount of water that it got? Let's look at additional definitions of confounding in the real world to help us understand its meaning. I know that confound is probably a new word to most of you. From Merriam-Webster, we have a very simple definition: to surprise and confuse someone or something, or to prove someone or something wrong. Take a moment, think about how this relates to the definition that we just discussed in our statistics example. I'm going to give the full definition from Merriam-Webster for confound. It says to throw a person into confusion or perplexity, and to fail to discern differences between, mix up, to increase the confusion of. And these two definitions really closely tie the common day usage of confound to what we use it for in statistics. Take a moment to think about what that relationship is. So when we think about confusion, we may not be certain which of these variables might actually be causing the response variable to be measured in a certain way. We can't discern the difference, and we might even be mixing up what we think is the cause of that response variable. I think that if we use one of our research questions from the previous video, we'll be able to explore this idea of confounding a little bit more deeply. Does practicing yoga decrease blood pressure? So we're going to look at both an observational study and an experimental design and see what might be the source of confounding in these two examples, if there is. So for an observational study, let's say that we use random selection, as always, to take a simple random sample of 50 adults. First, they will answer this question: approximately how many hours of yoga do you practice each week? Then, our researcher will take their blood pressure and determine if there is any difference, or rather, if those doing yoga have significantly lower blood pressure than those doing not practicing yoga. Notice in this example, our researchers did not impose any treatment on the subjects. While they did measure a response variable, blood pressure, in relationship to the explanatory variable, hours spent doing yoga. Let's say results from this observational study shows that the blood pressure of those practicing yoga is significantly lower than the blood pressure of those not practicing yoga. At the end, we still cannot make a claim about cause and effect, that doing yoga lowers blood pressure based on the study. Why not? Well, this has to do with the idea of confounding. So why is this observational study susceptible to confounding? Well, what if there are other variables that we didn't look at that might also affect a person's blood pressure? For example, what if people who did yoga also happened to eat very healthy? We didn't ask folks about diet, but maybe that's why their blood pressure was lower. Or, What if people doing yoga tended to work less stressful jobs or be in better relationships with their partners? All of these variables in part could contribute to the person's blood pressure and are therefore confounding variables. Can we as researchers be truly certain that yoga is responsible for low blood pressure for each of the participants? Now let's take a look at what would happen if we address that research question, does practicing yoga decrease blood pressure, in an experiment. So suppose we started off with 50 volunteers. We would randomly assign 25 of those volunteers to practice yoga daily for 30 minutes, and the other 25 would be randomly assigned to 30 minutes of quiet daily. You can think of those 30 minutes of quiet as a placebo because everyone in the experiment must receive some treatment. The researchers would measure blood pressure at the beginning of the month and at the end of the month, and they'd want to measure the change in blood pressure. They'd be hoping to find a decrease in blood pressure, especially for those practicing yoga. At the end of the month, the researchers would compare their results and see if there was anything statistically significant in the decrease in blood pressure for the group of people practicing yoga compared with the group of people not practicing yoga. This would allow the researchers to make a cause and effect conclusion. Our experiment here is not susceptible to confounding. For homework, I want you to think about why that is. Take time to go back through the video, look at the experimental design again, compare it to the design of the observational study. Also, feel free to go back to previous videos where we looked at the 4 principles of basic experimental design. Write your response down so that you are prepared for our discussion tomorrow. Again, you want to think about why is a well-designed experiment such as the one we just came up with not lead to confounding.